Our next presentation is Station Selection and Setup, presented by Adolfo Garcia of the California Air Resources Board.
Thank you and welcome to my presentation. My name is Adolfo Garcia. I'm the supervisor for CARB's Southern Monitoring Group, and I will be speaking today on factors surrounding air monitoring, station selection, and setup. For today's discussion, I've drawn on recent experiences that our section has faced over the last 2 years and organized the process as we've experienced it to arrive at this outline that I'll be following today. There's definitely more to it than just finding a shelter and setting up shop. System modifications. This is the term EPA uses when there is a change to the existing monitoring network, although it also refers to the discontinuation of a monitor or site, which is not going to be covered in today's topic. Under administrative requirements, we'll discuss the steps taken to communicate your intentions to our colleagues at EPA should you need to start monitoring or move an existing site. We will also cover the steps to consider and plan for within your district or agency that should be taken into account when navigating the process. By and large, monitoring networks are pretty static. Our last new site was initiated over 15 years ago. However, in my tenure, we have relocated 5 out of 14 and are currently in the process of moving one more. These moves were typically planned with ample notice, but some have been quite rushed. The potential for starting new sites is always there with the advent of new regulations, changing populations, or other factors, considering our latest site closures resulted in 2 districts assuming the monitoring obligation at new locations. Generally, the process of starting a new site or relocating one are similar, considering you'll need to send EPA a letter. For a new site, this request letter is where you'd outline your intentions and request an AQS number to make it official. Relocations get a bit more complicated, as there are requirements to address in your letter. Still, for either case, stakeholders will need to be notified. There should be no surprises for anyone. Outlining your intentions and reasons in your annual network plan ahead of time should suffice as a notification, but politically there may be other parties that merit a courtesy notice. For example, at CARB, we have several client divisions and operate stations and districts that rely on our data for their annual network plans. Region 9 liaisons should also know as soon as feasible. They can work with you and offer guidance in the process, as a delayed relocation can result in data loss if you shut down before completing a move. Also worth mentioning, if moving, changing your site's AQS number can affect an area's 3-year design value determination. As for new site letters, here I refer to the letter that San Luis Obispo County APCD used last year to initiate a new site as an example. As I'd stated previously, they initiated a new site to monitor in the city after our site closure. Administratively, since the monitoring was shuffled between 2 agencies, we at CARB had requested a discontinuation and the district subsequently requested initiating a new site. For the record, I've just included the text here for illustrative purposes and not for you to refer to during the presentation. So essentially, they started with an introduction followed by some background, which addresses factors leading up to the request. They included a monitoring plan highlighting the monitoring goals, intended parameters, etc., and included an acknowledgement of parameters that were not going to be monitored. They had opted to continue PM monitoring, but not ozone from the prior site arrangement. They also made a reference that this intention had been laid out in a previous annual network plan. In the request section, they state that they seek formal approval, an AQS number, and confirm the address. For the most part, it can be considered formulaic with no analysis required, and like I did, you can always find examples in annual network plans to model your request should you need to. Now for relocations. A relocation is a bit more involved and could possibly be its own training topic. Approvals are dependent on how well the proposed location mirrors the representativeness and meets the intended monitoring objectives of the old site. So the replacement site should measure similar concentrations from similar sources and represent the same spatial scale as the original location. Since nearby is subject to interpretation, the case-by-case approval process means your letter will need to include evidence to make your case for acceptance. There may be times when you're effectively kicked out of a site, like we once were at our original Arvin location, so one would still need to go through the approval process to relocate. As I mentioned before, there can be design value implications if a new AQS number is requested. EPA has informed us that AQS numbers can be linked between sites. However, we're still working through that process so that continuity is preserved with no missing data affecting a design value determination. My advice on design value sites is not to relocate them. However, if you have to move, a very detailed letter would be in order. In my experience, the driver behind parallel monitoring was always a bit murky, with distance from the old site being thrown about as the main consideration when faced with relocations. Coincidentally, while preparing for this presentation, I fielded this very question from a colleague and dug around until I found a network modification guidance document that was provided by our Region 9 colleagues in 2017. In it, they cite an AMTAC, Air Monitoring Technical Advisory Committee, parallel monitoring guideline, which dates it somewhat, but here it is. I opted to violate the PowerPoint tenet against text walls and presented it directly for completeness and use as a future reference. Suffice it to say that parallel monitoring can become required at key sites to establish that the pollutant concentrations at the new site match or exceed the pollutant concentrations from the old site. The resulting data becomes your weight of evidence in your case, establishing why the location is an acceptable replacement. Internal agency factors are what I call the administrative hurdles you have to navigate within your own agency. So we have funding cycles, which consist of fiscal years, budget allocations, EPA grant cycles, etc., essential for paying for the impending project. Approvals. At CARB, we often have to work across several divisions up to and including the executive office to get a green light. At some districts, this can require navigating up to your county board of supervisors for a vote. Leasing. At CARB, this is a two-tiered process where we work internally with the facilities management unit, and then they work with the State Department of General Services to negotiate all leases and agreements, which adds to the process. At one time, for placing shelters or trailers, we were able to work with land use agreements and hold harmless agreements. So I suppose your agency's legal department could be another internal agency factor. Contracts and procurement can cover a lot of action items, usually in the form of paperwork that are necessary in order to acquire what will be needed for your site, from stairs, railings, ladders, to equipment purchases, building improvements, utilities, etc. Once you've secured the funding, of course. And now for a funner topic, site selection. This is the part where you start to look for a location that meets your requirements, some of which have been listed already, that will eventually make it into your EPA letter. If you'd like a good idea of what these would be for your specific case, there are detailed monitoring descriptions spelled out in the respective annual network plans. As an operator, it is very informative to look up the role your assigned sites play in the network. In a few sites, I'll go over an example that we recently experienced in working to relocate our Visalia site. I will admit that here at CARB, we in monitoring are fortunate to have a top-notch planning group that gives us a lot of support in this area. When narrowing down an area to locate your site, you'll have to decide on what the actual facility will be. Until sensors relieve us of all monitoring duties, we have to decide if we're going to go with a fixed building or a drop-in shelter or trailer. At CARB, we have a healthy mix of both. However, the older I get, the commercial building gets the edge. Landlords handle maintenance and repairs, especially with things like air conditioners, and there's a higher likelihood of having an on-site restroom. Shelters open up opportunities to be in different, more diverse areas like schools or parking lots, but may require more infrastructure improvements like connecting to power and internet. You'll also need to pay attention to your specs if it's built to suit, and schools and the like may limit access during holidays, etc. Now, a quick mention on how you find a location. For starters, you have to work with your administrative process, but you can also pound the pavement, knock on doors, leverage contacts, etc. Do you know somebody that knows somebody on the school board? You may have to put yourself out there. I would also say the emergence of networking with community groups has the potential to open up opportunities in this area. Once you've isolated a potential location that meets your site selection criteria, you'll have to determine if it will meet the CFR-defined probe and monitoring path siting criteria. Although I've covered the big three here on our slide, these criteria also cover the placement of the inlet probe, spacing from minor sources of pollution, spacing from obstructions to the monitoring probe, probe material, and residence time. It is worth mentioning that these latter criteria can often be worked around during the site setup with some ingenuity, such as raising the probe at the expense of your residence time. But roadways, obstructions, and trees can be deal killers, with waivers from the EPA being your only possible out. Now, trees can scavenge SO2, ozone, and NO2 by absorption and provide surfaces for particle deposition. Trees also act as obstructions, and special attention should be made to adhere to correct spacing. But in this slide, we're going to address drip line. To quote the CARB Quality Assurance SOP, the drip line rule is most simply interpreted as follows. There shall be no vegetation, such as branches or leaves, within 10 meters of the probe inlet at a height higher than the probe inlet. A 20-meter drip line is desirable and provides a buffer for vegetation to grow over the course of a year. This is a picture of the Calexico site, the previous one, and yes, the drip line was one of the drivers in seeking a relocation. When the site had started, there were no trees there. Now on to obstructions. The 2-to-1 rule simplified. Starting from the site's probe inlet, usually 2 meters above the roof line, give or take, any area obstruction in a 360-degree arc, we just have a nice simple two-dimensional side view here, has to be more than twice the height difference from your probe to your obstruction height, shown as H here, whether it be a tree, building, or whatever you might encounter out there. For geometry fans, the angle in the resultant triangle works out to 26.6 degrees. The tree in this drawing on the left is at the inlet height, so as long as it's more than 10 meters away, for the drip line rule, it's not a problem here. But remember, trees grow. We'll see another example coming up in slide 22. These are simplified examples. However, keep in mind that the CFR includes criteria for the separation required between monitors, walls, parapets, and structures. Now on to spacing from roadways. Ozone, NO2, and PM are susceptible to interference from roadway emissions. When siting monitors, this criteria is intended to minimize roadway interference. In the guidance documents, there are tables which determine the required distances your sample inlet must be placed based on nearby vehicular traffic. In this example, from our Calexico site, we went through this exercise while figuring out where to place our shelter. Originally, we had planned for an east-west orientation. However, when we evaluated the annual average daily traffic numbers for Highway 98, it was apparent that the original layout would not work. So we opted to use the 40-foot length of our shelter to our advantage and rotated it 90 degrees, allowing us to place our probes for gas and BAM further away on the south side of the shelter. As an aside, since it had been built to our specs, we had to make sure that the electrical panel would be adjacent to available power, and this then determined which way our door would face. It was critical to do all this before the shelter was dropped off. We only got one drop off. Any rearrangements would take months to have to execute a contract. Currently, we're running on borrowed time to relocate our Visalia air monitoring station. It's one of our older sites and important for ozone and PM, but the landlord has informed us that they will not be renewing our lease. Fortunately at CARB, we have a facilities management unit and the air quality planning and science division, the latter which, upon request, identified 3 acceptable zones for us to pursue. In their analysis, our AQPSD considered 24-hour back trajectories on all ozone 8-hour exceedance days, plotted on the left, as well as provided several windrows plots covering different seasons between 2017 and 2019. The first hurdle has been working through our internal administrative process. As you can see from the red X's, we've had a few false starts that have fallen through. I've found it's challenging to stick to a linear process like the tidy outline at the start of the presentation, since we rely on an outside agency to negotiate with property owners. So it requires a degree of flexibility within the process. For example, we might give our stakeholders an early notice of a proposed site, even though there's a chance it might fall through. We can always go back and correct that. But there's no way we're going to draft a letter to the EPA until we know that we're going to have a lease in hand, or we can't fully budget for improvements until we know what type of site we're working with. Applying the analysis that has been provided for us, we have a good idea that this candidate site will meet the relocation criteria. So while our facilities unit draws up lease paperwork and scope of work documents outlining site improvements, we're opting for a commercial building, by the way. Things are looking good. From the planners, the scale and concentration representativeness look good, along with the drip line from the tree adjacent to the building on the north end. Also, a cursory check of the traffic on the main roadway on the left passes muster as well. However, applying the other component of siting, obstructions, reveals some problematic trees that potentially violate the 2-to-1 rule because they're sequoias and they're tall. With respect to this rule on obstructions, there exists the 270-degree arc rule. This states that there must be unrestricted airflow of 270 degrees around the probe or sampler, or 180 degrees if the probe is on the side of a building or wall, which won't be the case here. The 270-degree arc rule can be interpreted in two ways, either continuous or cumulative. In our case, things are looking good, as the windrows patterns provided by our planning group, one of which was in slide 18, give us confidence that this site would allow for application of the 270-degree arc rule. With the trees on the upper right appearing to be ideally situated in a 90-degree cluster and out of the way of prevailing winds, we expect that they will not adversely affect siting. Now on to equipment selection. Formally, any monitors you deploy will need to be EPA designated reference or equivalent methods per 40 CFR Part 53. If you've never done so and you have some free time in an air monitoring station, you can take a moment and look for the labels with the numbers on them. Also, these are readily available on the EPA's website. Most agencies will already have in-house specifications, but some of the factors you'll want to consider are range. Lower level trace units are becoming commonplace, maybe more so as audit levels drop, so MDLs and response times are important. On the back end, you'll want to specify the signal output so that you maintain network compatibility. Now, new technology in monitors is great, but remember, per the CFR, within a PQAO, 15% of primary monitors of each method must be co-located. So if no one else is using it yet, you might be deploying two. Similarly, you need to ensure that your calibration standards work with your new monitors, or you will be adding to your procurement list. Asking around is a great resource, and there are opportunities within our community to do so. I've even gone so far as to ask a manufacturer for references and spoken with out-of-state agencies before for their impressions and experiences. On this slide, I've listed some of the items that come up when you get to the setting up phase of setting up a site. The list is no way comprehensive since every site is unique, but at a minimum provides a starting point to build off of. Also consider that some of these items will need to be addressed in your procurement phase and help determine the actual cost you'll need to budget for setting up shop. If you've opted for a shelter, the distance from available power will be a key factor since line extensions by the power companies are very expensive and time-consuming if permits are needed. At our Calexico site, we were close enough for a power drop, but had a healthy bill from the internet service provider to run cable out to our shelter. And now a little word about power. Much like a house, power comes from the transmission lines to your power meter, which is then connected to your electrical panel, which houses the circuit breakers that protect the individual circuits wired into your shelter or building. The ratings on these components are important to ensure the safe, continual operation of your station equipment. The standard for most household circuits are rated at either 15 amps or 20 amps. An important point to remember is that circuit breakers should only handle about 80% of their overall amperage for periods longer than 3 hours. That means a 15 amp circuit breaker can handle around 12 amps and a 20 amp circuit breaker can handle about 16 amps. 100 and 200 amp panels are common, and a rule of thumb is the more the amperage, the merrier. But high power needs can get complicated very quickly. It's best to consult a commercial electrician or contractor anytime questions come up. Looking at some of the sample usages that I've prepared, considering at ARV we used gassed pumps, 2 BAMs on the same circuit would start getting close to the safe zone on a 15 amp circuit. This would be a good reason to consider METOs if your outlet situation is constrained. And now I'd like to share a little bit of research on air conditioners. I've done plenty of reading on the internet, so that kind of makes me an expert. Not really. However, the first rule of thumb that I discovered was to multiply the room area by 25 to get the number of BTUs to get adequate cooling for that space under different weather conditions. In this case, converting the dimensions and resulting 8,000 BTUs of our Connex shelter results into a unit of about 3/4 ton. However, at our Calexico site, which happens to be an 8-foot long by 40-foot wide Connex shelter, we placed one on either side of the shelter, having backup, and opted for 3-ton units, so your mileage may vary. In our recent experience at Visalia, the building contractors working on our site have asked us to take the power usage off the instruments to help them come up with a proper spec. So that might be a better way to go. Lastly, if you're building a shelter to your own specifications, you'll also want to take into account insulation ratings to wring the most efficiency out of your HVAC systems. Here, referring back to our Visalia experience is an example showing some of the site details prepared by our State General Services professionals to prepare the location to be a CARB air monitoring site. You'll notice a reference to the AC on item 17, hatch access, etc. as item 21, and a specific electrical callout on the roof for our SAS in item 19. Railing on the roof, dissipative mats, etc. are included, and so you'll notice the details can pile up once you commit them to a plan. Over time, we've developed a tool to help with the planning when relocating a site. It helps make sure we communicate with the proper party at the proper time to try to coordinate these tasks. We've gotten good feedback from our business partners during the planning stages, since, as mentioned before, it avoids surprises with the people that are there to help us. With the Calexico relocation, after literally years of delays, we were hit with an urgent request to finally move the facility. For our planning, we included an interim phase where we included the possibility of continuing monitoring out of a temporary shelter while waiting for improvements to the final site to avoid data loss. These items are represented in an Excel sheet on the next slide. Here we have a section of the Calexico move plan as an example. Our administrative colleagues were very appreciative when we presented it to them. So between the vacate, interim, move-in phases, there were eventually over 30 individual action items. Now, as for setup and integration, this slide almost didn't make the cut as it started to overlap into the area of operations that many of us are familiar with. However, there are always minor details to keep in mind that bear repeating, and a few reminders couched in here that could easily be overlooked, such as notifying QA for getting on the audit schedule. We recently had an auditor show up at an old site, not having been advised of the new location, as well as notifying CARB's Air Quality Planning Science Division so that the ACMIS2 data feed can be updated. And there's even the likelihood of notifications within your own agency if the roles and responsibilities have to be observed between laboratories, operations, and quality control functions. Now, to address layout, we've played with rendering software to mock up and arrange monitor and sampler layouts down to the roof penetrations for BAMs in order to speed up the setup portion. These renderings have come a long way from pencil diagrams sketched on loose leaf sheets. Again, it's best to consider BAM penetrations as a fixed point that will typically have to be worked around when determining if there is adequate space for the rooftop samplers to maintain the 1 and 2 meter distances between sampler inlets. If we could add individual circuit locations into this, we'd really have something. Also, one trick we borrowed from Ventura County was to turn our racks at an angle so that they're easily accessible from the front and back, and the interior space is optimized. And now for final thoughts. But before I begin, I'd like to say that I've included 2 more slides behind this one with reference materials covering EPA discontinuation or relocation letter guide and general references from the CFR to add to your light reading list. As you may have discerned, there's no one-size-fits-all solution. Each site has to be evaluated on a case-by-case basis with the intended monitoring objectives of the site in question driving the details. I'd advise you to organize the process and retain this information and experiential knowledge you've learned, whether technical or administrative, for you and your coworkers to be able to apply for future projects. For design value sites, they typically cannot be removed if specifically required by an attainment or maintenance plan, even after meeting the standard. Nonetheless, it has been done with a very detailed letter to EPA. Kicked out is kicked out. Also, parallel monitoring could provide compelling data for obtaining an approval. What does the future bring? I've seen recently presentations on all-in-one rooftop sampling units. So maybe it's promising that for simple sites, you could just lease roof access, although the logistics and integration will still need to be worked out. Finally, the original pitch to me for this presentation was location, location, location. But I find site selection to be more like camping. When you get to choosing a spot, take everything in around you and you ask yourself, will this one do? Thank you.
Great, thanks, Adolfo, for that presentation. Looks like there was one question not related to Zoom issues. Sorry about that, everyone. Orlando had said tools used for the rendering of the station setup. I think maybe he's asking for some.
In that drawing, we had a staff person who got real familiar with the application called SketchUp, and that's what was used. And it was really handy.
Grace, you're muted right now, but if you have any additional questions, please go ahead and send them through the Q&A at the bottom of your screen.
So other departments that you recommend to get involved in the moving of a site?
It would depend on your agency. With us, we've got our data groups, we've got our administrative groups, so we have to deal with them. And so the data groups are helpful early on in identifying like zones that we can concentrate on, and expediting the leasing process that can take quite a while. And so for districts, it's a little bit more compact, but at any point, any of our district colleagues are free to ask us for an opinion or for assistance, and we typically will do what we can.
Did the new shelters already include inlet holes and ports? Looking sharp.
Hi, Chris. We had to define those, and so we mapped out the dimensions of a BAM and figured out where they would go. To cheat a little bit, we spec'd them like 2 to 3 in a row to give us a little bit of wiggle room in the event that we overlooked something. And so that was the best way we could ensure that there wouldn't be any problems with doing them ourselves and inducing leaks and stuff like that. And so they're permanently capped and supported by the manufacturer. So we try to do our homework as best we can, best we could, to ensure the spots. And like I said, those are fixed points. So all of our 1 meter and 2 meter distances are going to be based off that. And so in the Calexico case, the reason why we went with a 40-foot shelter wasn't for the interior space. It was for the roof space to ensure adequate sighting of all the monitors.
All right. We've got a comment from Eric. Don't forget, as Adolfo mentioned, to notify the QA section at CARB. Orlando said, is AirBias or PQAO willing to take over some of the workload when moving a site?
Workload. We have a resource request form for that. You know, I mean, everything's subject to discussion. You know, we'd entertain it and help where we could.
And Monica said, could you repeat site relocation, because we did not hear that. These presentations, just FYI, are going to be up on FeedLoop still for you guys to view, and hopefully with no technical issues. But if Adolfo, if you could answer that briefly, and then we do have a break until 10:45 after that.
Well, repeat site relocations.
Or do you, Monica, could you, do you have a specific?
How much time do we have?
I know. Well, maybe Monica, you could shoot Adolfo an email or a chat in FeedLoop with your specific question. Sorry about that. Thank you. So we are out of time for this session. We have a break right now until 10:45. Then our next session is going to be sample handling operations. So we'll see you all in a little bit. Thanks, Adolfo.